and y is the life expectancy. And the table is 0 with 74.83, 2 to 75.10, 5 with 75.90, 7 with 76.18, and 76.33. So first I have to enter the data in the calculator. So in stats, I edit, and I am going to edit two lists. So clear everything I have. So the first list has 0, they have to be in exact the order that we were given, 0, 2, 5, 7, and 10. And then the y coordinates, 74.83, 75.1, 75.9, 76.18, and the last one, 76.33. Once I have the data set in, I would like to change the viewing window. 0 to 10, I'm just going to put -2 to 15. So -2 to 15, let's say with a scale of 3. And then y goes from, let's say, 70 to 80. With a scale of 2. Now, the reason I would like to look at the scatter plot is because I want to make sure that there is a linear regression. So I go to second and plots, enter, I turn it on. Yes, list L1 is the x value, or the list of the x values. L2 is the list of y values, and this is the symbol for the scatter plot. I adjusted the viewing window so I can see those points. I prefer, it doesn't matter, you can change the marks, you can change the color. So I just click on graph. Yes, oh, I also have something else in there which I don't need. Okay, so I see the graph, and it appears to be a strong linear regression relationship between, or a strong linear relationship between the two variables. Because I am going to graph as well, I'm going to graph the linear regression line. So now I'm ready to do calculations with the data I have, and it's number 4, the linear regression. The first list is list L1. That's where the x values are. The y, obviously, list L2. And I want to store the linear regression, so I don't have to type it in. I don't want to type it in. I go to variables, y variables, function, and I want it function y1. And now I want to calculate. And I'm going to write, this is the so-called y hat, the predicted y hat, 0.162866 x plus 74.886242. So now I want to graph both. And it looks like the linear regression is line, which is the line of best fit, minimum error. That's why it's in this chapter, minimum error. The line that may or may go through some points or not, it doesn't matter, but it's the line of minimum error. When we talk about minimum or maximum, we talk about calculus. Now, the problem should also ask predict la la la. So it says use a regression line to predict the life expectancy of man in 2025. So we know that x equals 0 represents 2004. So this is 21 years later. So when I go to the calculator, I just simply plug in 21. That's all I need to do. And the life expectancy, they did not predict, however, the pandemic. So when x equals 21, in other words, in 2025, it appears that the predicted value, assuming the model still holds, is 78.31 years. And that is the concept of the linear regression. So I entered the data exactly as it was given to me. I plotted the scatter plot to see whether I'm going after a hoax or this is true. Yes, it was true. I saw the scatter plot. It appears that a line could fit through the cloud or the scatter plot. And then I use the linear regression in the stats. Once I had the linear regression line, I already entered it, so I don't have to plug this in by hand. And then I plugged in 21 to get what they wanted. Now notice that 21, to be honest, is way outside of the data. So if it's 11, if it's 12, if I want to predict 6 or maybe 8 or 9, it makes sense. But 21 years later, it doesn't really make that much sense because we don't know if the model still holds that far out. So it's iffy to predict, to use the data from the year 2004 to the year 2015 and predict 2025. Very iffy. It may not be a reliable figure. So we have to make sure, well, when we predict, we should not use this model to predict too far out because it may not hold. Good. Next question. Anything else?
I don't mean to jump around, but could we do question 36 on 291?
Yes. We are jumping around. We should. It's a good idea to go from one thing to another and review everything we need to review. Okay, 36. Yes, sure. In 36, let me copy. F prime of -1 equals 0. F double prime of -1 is greater than 0. F of -1 is -5. F prime of 7 is 0. F double prime of 7 is less than 0. F of 7 is 10. F double prime of 3 is 0. And F of 3 is 2. Who knows if I copied everything from 36 or I mixed them up? Now I have to check. F prime of x, yes, that's correct. F double prime of -1 is greater than 0, correct. F of -1 is -5. F prime of 7 is 0, correct. F double prime of 7, less than 0. Okay, F of 7 is 10, good. F double prime of 3 is 0, and F of 3 is 2, perfect. Okay, it happens that I copied from one problem. Okay, so this is gibberish. I have no idea what this all means. We have to sort it out first. So F prime, F of x, and F double prime. Okay. Good. F prime of -1 is 0. So let me look at the numbers so I don't have to. So -1, 3, and 7. Okay, -1, 3, and 7. Okay. F prime of -1 is 0. F double prime of -1 is positive. F of -1 is -5. F prime of 7 is 0. F double prime of 7 is negative. F of 7 is 10. F double prime of 3 is 0. And f of 3 is 2. Now it all makes sense. Good. So let's analyze what we see. At -1, the function has a critical number. The value of the function at -1 is -5. So when I graph, this is my first point, -1, -5. At this point, as you see, the function opens up because the second derivative is positive. And this is a critical number. So this must be a relative minimum. There is no other way. So the function does something like this. Continue analyzing, and then we graph. Here's another point, 3, 2. What happens here? At this point, at x equals 3, the second derivative is 0, and it changes sign. So this, by definition, this is the definition of an inflection point. Again, at 3, the second derivative is 0. The point is 3, 2, but the second derivative is 0, and it changes sign from opening up to opening down. And this is the inflection point. Finally, at 7, the function has a critical number. The point is 7, 10, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 8, 9, 10. I missed it. Sorry. So as you see, the second derivative is negative, which means that the function opens down. If it opens down and this is a critical number, this must be a relative max. There is no other way. And now I know exactly what I have to do. Relative min, inflection point, relative max, done. Yes, it can be sophisticated and do other things and so on and so forth. You can put a vertical asymptote somewhere. No, this is the simplest possible graph that fulfills the given conditions. But this is possible because of this table. Without this table, looking at this is gibberish. I will never be able to understand what this means. But organizing it as I taught you with this table makes it extremely clear. No ambiguity whatsoever. Very good question. Good. Next question, next problem, next topic. We can go back to chapter 6. We can do whatever you need. Just name it. Browse through the topics. I would definitely, if I were you, I would review all the reviews for all tests and the final exam review in preparation for the final exam. Is this clear? Is this problem okay, everyone?
I have one more question.
Any question?
Can we go over problem 44 on, it's either 276 or 278, I'm not exactly sure.
276 or 278?
Yes.
It doesn't matter. We'll find it in a minute. Okay, here it is. So let's try 278. And let's see, and you said 44. Good. 44. This one. So what are we asked to do? Find any relative, okay, a max, min, so the whole thing, and then sketch a graph. So this is 44. Is this the one you went? K of x, x e to negative
Yes.
3x? Okay, perfect. So k of x equals x e to negative 3x. Good. So they want us the whole thing. So of course, I'm going to get the table going. K prime of x, k of x, and k double prime of x. This has no restrictions. This is always a positive number. This is positive or negative, but there are no restrictions. Even if you write it like this, which is fine, but e to the x is never 0. So this function is defined everywhere. There are no restrictions whatsoever. So the function, first of all, I have to determine the function value at 0. So the top is 0, the denominator is 1, so that is 0. And this cannot be equal to 0 at any other value. This is it. Now I have to determine the limits. If you remember, I start with the function. I find limits, I find x and y intercepts, asymptotes if there is a case, but that's not here, and so on and so forth. So the only thing that I have to find is the limit at negative infinity and the limit at infinity. So let's do just that. And then we'll continue with the first derivative and then the second derivative and so on and so forth. So limit as x approaches infinity from, I'm debating with myself how to write it. Okay. So what happens here, the numerator is infinity, the denominator is infinity. However, the denominator is way stronger than the numerator. So we haven't discussed something called L'Hopital's rule. L'Hopital's rule allows us to determine a limit only in the situation of infinity over infinity or 0 over 0. And we are allowed to differentiate. There is no need, but I'm just explaining how we can prove that the limit will be 0 in this situation. Because the numerator, when we differentiate the numerator, we get 1. When we differentiate the denominator, nothing really happens. This stays extremely strong. And as we know, 1 divided by huge approaches 0. So I know that this is 0 and y equals 0 is a horizontal asymptote at infinity. I haven't determined anything here yet. So I also have to find limit as x approaches negative infinity from x e to negative 3x. And here's the reason why I left it like this and not in the fraction form, but I used the original function this time and not here. Here's why. When I replace here x by negative infinity, I get e to infinity. So this will go to e to infinity. This piece will go to negative infinity. Well, e to infinity is infinity. Negative infinity times infinity is negative infinity. So there is no horizontal asymptote at negative infinity. It goes to negative infinity. But there is a horizontal asymptote only at infinity, which is 0. Okay? Kind of strange. How can it jump from 0 to 0? Okay, so we'll see what happens here. Now the next step, so I already have some questions, because this is definitely 0, as x approaches infinity. No questions here. Definitely here on this side, this is infinity, so it goes to infinity times negative infinity is negative infinity. This is clear. Okay, so let's move on to the first derivative. So let me write k of x again here. So let's say, okay, so the first function prime is 1 e to negative 3x plus x times e to negative 3x times negative 3. I will factor out e to negative 3x, and I have 1 minus 3x, and this can never be 0. The function is never undefined, but k prime of x can be 0, and 1 minus 3x is 0 when x is 1/3. Aha, aha, I see it now. Okay, so when x is 1/3, the function has a critical number. I have to, with a calculator, I have to plug in 1/3 and see what is the y value. But for now, I need to study the sign, left and right, of this derivative. This is always positive, and this, when you plug in 0, you get a positive number, and when you plug in a positive 10, you will get a negative number. And now it makes sense. And now this makes sense because it's a maximum and then comes back to 0. Good. So I have to plug in 1/3 to determine this value. And this is the relative max. 1/3 comma this. But I have to punch in the function in the graphing calculator and put 1/3 in it. Okay. So here's y equals clear, and I also want to de-highlight that. Okay, so x times e to negative 3x. Good. So all I want for now is just plug in this tiny little thing of 1/3. Okay, and I get a very small number, of course, 0.12. Okay. Now I have to make sense of these two rows. I cannot continue before I make sure that these two rows work well together. If they don't, something is wrong. So from negative infinity to 0, yes, that's true. Although very tiny, from 0 to 0.112, that's true. From 0.112 to 0, yes, that's correct. So for now, I'm happy. The two rows work well together. Now, let's see what we do with the second derivative. That's ugly. So I'm going to copy the first derivative. Let me see if I have to, yeah.